So, welcome to Exam 1 Review, Chapter 4, Part 2. I think this will be the last part that I do today. Um, so we covered some of the basics of it now, so let's just actually work on a bunch of problems straightforward and hardcore. Here we go. So this is number 37 and 43 from page 221 in your book. We're given a few matrices, and I wrote these down ahead of time in order to save a little bit of space. So the question is, what is B plus A times D? The first thing we always do, is to check to make sure that we can do this. So we have A, which is a 2 by 3 matrix, and D, which is a 3 by 2 matrix. So we can do this multiplication, and that will give us an output matrix that is 2 by 2. B is a 2 by 2 matrix, and we can add a 2 by 2 matrix to a 2 by 2 matrix. So this is definitely something that we can do. So let's just break it up into parts. Let's do A times D. So we'll start with A and D. So let's just write them down to 0, minus 1, 4, 3, 2, and 3, 0, 1, minus 2, minus 1, 2. Now recall that our output is going to be a 2 by 2, right? So we do row by column. So 2 times 3, 6, plus 0, plus 3. Second column, minus 2, plus 1, plus 6. Second row, first column, 0, plus 0, plus 2. Second row, second column, 0, minus 4, plus 4. So that will equal, I'm going to write down B over here, and so I can just bring this down, okay? So we have minus 3, 2, 1, and 5. I'm changing my glasses so I can see a little bit better. There we go. And then, excuse me, plus 9, 2, 7 minus 2 would be 5, and this is a 0 here. Adding these directly together, we have 6, 6, 2 plus 2 is 4, 5 plus 0, 0 is 5. So this is our result. Okay, so this looks a little bit complicated. Let's take a look at number 43. Now remember, the first thing we always do is we check to see that we can do these operations. So we have this is a 2 by 2. B is a 2 by 2. A is a 2 by 3. We can do the operation. The output will be a 2 by 3. Okay. C and D. C is a 3 by 3. D is a 3 by 2. We can do this operation. The output will be we can do the operation. The output will be a 3 by 2. And then this is an addition. So for the addition, they have to be the exact same size, same dimension. A 2 by 3 and a 3 by 2, they are not exactly the same, so this is an undefined operation. And that is our answer for that. And we can just write that down. And I'm happy, because otherwise there'd be a lot of multiplication to be doing on in there. Okay, next problems. From page 233, number 17. We wish to just solve them. We take a look at this. The first thing you should notice, and you should notice it pretty fast, is this is the identity matrix. So this is the identity matrix. Knowing that any matrix times identity matrix is the matrix itself, we can just write down the solution as minus 2, 2, 5, 1, 4, 1, 3, minus 2, 0. You don't actually need to go through the calculations on this. If you really want to, you certainly may. Find the inverse. There's a couple different ways we could find the inverse. We could, and we'll perhaps, I think we should probably do it both ways. But the first method is, let's use the determinant method. So the determinant of this is, we'll call this A equals, so the determinant of A equals minus 4, minus 4, minus 4, which equals 0. So the determinant is equal to 0. So this is a singular matrix. There is no determinant. Huh. Okay. There's no determinant. There's no inverse. I'm sorry. The determinant is equal to 0. It's a singular matrix, which means there is no inverse. So you can just write singular for that. Let's try it another way. Let's use the augmented matrix method and see if we end up with a similar result. 1, 2, minus 2, minus 4. Remember, augment it with the identity matrix. 1, 0, 0, 1. We're going to subtract 2 times row 1. So row 1 is going to stay the same. And row 2 minus 2 times row 1. That will give us 1, 0, minus 2. Let's see. Minus 2 times minus 2 is 4. Plus a minus 4 is 0. Right off, this tells us that there is no inverse. We can stop right here. We'll have a row of zeros on here. Regardless of what ends up in this section, this tells us that there is no inverse. This is a singular matrix. Singular matrix. Singular matrix because of this row of zeros. So again, there's no inverse. Let's try it with this example. We're going to use the determinant method. So what is the determinant? We'll call this B. Determinant of B equals 2 times 3, which is 6, minus 4, so that equals 2. Okay, so B inverse is equal to 1 divided by the determinant times, we switch the 2 and the 3, and we negate the other ones, which gives us the result of 3 halves minus 1 half minus 2 and 1. So this is B inverse. Let's use the augmented matrix method to find this inverse. So here we have, let's augment the matrix. 2, 4, 1, 3, augment it with the identity matrix. Remember that you can use this for any size, you just increase. So the method is the same. The methodology is the same. I'm actually going to do 2 steps here. I'm going to divide the first row. I'm going to take 1/2 of row 1 and put that in row 1. But I'm going to use this term right away and take row 2 minus 2 row 1. Okay? So we'll end up with 1, 0, I'm sorry, not 0. 1 divided by 2. My apologies. 1/2, and here we have a 0. Here we're going to do row 2, which is 4 minus 4, 3 minus 2, 0, 0 minus 2, and 1 minus 0. We're actually almost done by doing that. So we've got our first pivot, and the column is cleared. We have our second pivot, we just need to clear the column. So let's just clear that column. So we're going to have row 1 minus 1/2 row 2. and row 2 will stay the same. So that gives us 1, 0, 0, 1. Row 1, which is 1/2, minus 1/2 of row 2. So 1/2 of row 2 is 1. So 1/2 minus 1 is minus 1/2. And then, I'm sorry, it's plus, isn't it? Because it's a minus, a minus, I'm sorry, this is a plus. So we have 1/2 plus 1, which is 3/2. My apologies. It just didn't seem right. So 3/2, and then we have row 1, which is 0, minus 1/2, minus 2, and 1. And that tells us this is our inverse, so B inverse equals 3/2 minus 2 minus 1/2 and 1. We'll notice that this is equal to this. So we do have the correct results here. Next up, that is page 234, number 37. And I also did number 53 from 234. We're going to do a couple others. And I may do more than just what's on here. In fact, I'm not doing number 17. It was pretty straightforward, so I'm skipping number 17. I'm going to do number 23 and then 29 from page 242. So how do we solve this? So basically, this is an equation, a matrix equation in the form of AX equals B. We solve this by doing X equals A inverse B. So we need to find the inverse of this matrix. Okay, we'll call this matrix A. Okay, so we need to find the inverse of this. How do we find the inverse of this? Typically, the easiest way, if it's a 2 by 2, then we use the determinant method. So that's what we're going to do. We're going to use the determinant method. Recall that you can always use Gauss-Jordan elimination with an augmented matrix, which is what we did in the second part here. And I think I'll do this one using the determinant method, and I think I'll do this one using the Gauss-Jordan method with the augmented, if that's okay with you guys. So we're going to use a determinant of this. This is called Cramer's rule. Recall Cramer's rule, which tells us that the inverse of this matrix, I'm going to call this A. So the inverse of A, so A inverse equals 1 divided by the determinant of A. The determinant of A is minus 3 minus 2. So minus 3 minus 2 times switch minus 3, 1, negate minus 1 minus 2. So that equals minus 2 minus 3 is minus 1/5. So this is minus 1/5. I'm just write it all down. Minus 1 over 5 times minus 3 minus 2 minus 1, 1. So that'll give us A inverse equals 3/5, 2/5, 1/5, and minus 1/5. We're not done. That's the first part. So X, recall, equals A inverse times B. So let's multiply this by B. This is a 2 by 2. This is a 2 by 1. So our output is going to be a 2 by 1. Sorry. row by the column. So 3/5 of 15 would be 9, plus 1/5 of 10 would be 2. And the bottom column is 2/5 of 15 is 6, minus 1/5 of 10, which is 2. If you're not sure where that's coming from, I'm going to do that real quick up here. 3/5 times 15, 1, 3 equals 9. Okay? So we have 11 and 4 is our resultant matrix. That's the result. So this is equal to X. This is the answer to that one. Let's try number 29. So this is similar. We're just going to write it out a little bit differently. So we have AX minus C equals B. Well, add C to both sides and we'll end up with AX equals B plus C. And then we can take A inverse of this and solve this. So then we can do X equals A inverse B plus C. Okay. So the first step of this is to add this matrix to this matrix. We're adding this vector 4, 3 to both sides. When we add it to the left-hand side of the equation, this becomes 0, and then everything's cool. When we add it to the right hand, we'll end up with 14 plus 4 is 18. 8 plus 3 is 11. So we end up with AX equals 18, 11. Now we wish to find A inverse, and we're going to use the augmented matrix method for this one. So let's augment the matrix. We've got 4, 3, 2, 1. We'll augment it 1, 0, 0, 1. Doing row operations, what shall we do here? Okay, we'll do 1/4 row 1. We could also do the determinant method. That's totally valid, but I'm going to do row operations on this, which gives us 1, 3. 2 divided by 4 is 1/2. 1 divided by 4 is 1/4. Now we're going to do, is everything showing up okay? Yeah. Now we have row 1 will stay the same, and we're going to do row 2 minus 3 row 1. 1, 0. 1/2, and then 3 halves, so 1 minus 3 halves is minus 1/2. Yes? 1/4, 0. 0 minus 3/4. And then 1. So I'm going to do 2 steps on this next one right away. Okay. So I'm going to do row 1 plus row 2. And then I'm going to do minus 2 row 2. So I'm adding a multiple of row 2 to row 1. And then I'm multiplying row 2 by a constant. When we do that, we have 1, 0. Notice that when we add 1/2 minus 1/2, we end up with a 0. 1/4 minus 3/4 is minus 1/2. 0 plus 1 is 1. The bottom row is we're dividing it by 2, so we're multiplying it by 2, I'm sorry, by minus 2, so we have a 1, and again this will be positive 3/2 and minus 2. So our inverse, we're not done here, and I'm going to just pull out a sheet of paper. We're getting close to the end. Let's see if we're doing this right. Okay. So this is what we did is we solved for A inverse, so this value is A inverse. Yes? Okay. So we're going to write that out. So A inverse equals minus 1/2, 1, 3/2 minus 2. We also have, so we have x equals A inverse times 18 over 11. So what we're going to do is we're going to multiply this matrix by this matrix, and that'll give us x equals minus 1/2, 3/2, 1 minus 2, 18 and 11. I'm just going to make sure that my autofocus is okay on everything. I think it is. Just verifying. There we go. Multiply, so 2 by 2, 2 by 1, we can do it, output is a 2 by 1, so that'll equal minus 1/2, which would be minus 9, plus 11, minus 3/2, or I'm sorry, 3/2. So a half would be 9 times 3 would be 27 minus 22. So x equals 2, 5. There we go. I'm going to do one more problem. This is the last one that I have. This is again on page 242. Maybe it's on 243. Anyways, it's just the whole thing. Solve this set of equations. How do we do this? And I'm going to do this two different ways. I'm going to use matrices. We're not doing substitution or addition by elimination or any of that. We're going to use matrices. We can set this up as a matrix equation, or we can set it up as an augmented matrix. And I'm going to do it both ways. If we set it up as a matrix equation, A equals 5, 2, 3, 1, and B equals 13, 2. Like I say, we're doing this a matrix equation way to begin with. So then we do A inverse. That equals the determinant, 1 divided by the determinant using Cramer's rule. So 1 over 5 minus 2 times 3 is 6. So it's a minus 1. Times, switch these, 1, 5 minus 3 minus 2. Which equals minus 1, 3, 2, minus 5. Then we have x equals A inverse B, which equals, we have all of these values, so let's go ahead and do that. A inverse minus 1, 2, 3, minus 5. B, 13, 2. Row by column, 2 by 2, 2 by 1. Output is a 2 by 1. So minus 13 plus 6, 26 minus 10. So x equals 7, sorry, minus 7, and 16. Yes? Okay. Now, let's do the same thing, only let's do it using an augmented matrix. So first step on using an augmented matrix is set this up as an augmented matrix. In this case, we've got 5, 2, 3, 1, augmented with 13 and 2. Looking at our pivots, let's just switch rows 2 and row 1, and at the same time that I switch them, I'm also going to multiply this by 1/2. Okay? So I'm going to do 1/2 row 2 and then row 1. So 1/2 of row 2 would give me 1, 1/2, 1, 5, 3, 13. Next step would be, we have our first pivot and it's equal to a 1, so we're going to clear out the column. Row 1 will stay the same, row 1, and then row 2 will be row 2 minus 5, row 1, 1, 0, this is 1/2, 1/2, row 2 minus, so 3 minus 5 halves, so 6 halves minus 5 halves would be 1/2. Is that correct? So 3 would be 6 halves minus 5 halves, 1/2. 1, and then 13 minus 5 is 7. Okay. I'm going to do another short, just an addendum correction to what I had done previously. So we're going to go back to this. I'm going to show you real quick. So I basically made a mistake right here. So this value is not 7. 13 minus 5 is equal to 8. So this should actually be an 8. So we're going to change this to an 8. And then we're going to recalculate. Up to this point, everything was okay. So we're going to change this one and then recalculate. And what we have is we have row 1 was minus row 2, and then 2 times row 2. Okay. And that will give us 1, 0, 0, 1, 8. 1 minus 8 is minus 7. And 2 times 8 is 16, which gives us x equals minus 7 and 16. And this time we do have agreement. And there we go. That is the correct result. Take care.